To code out our memoized Fibonacci algorithm, we are going to start by defining it as a function called fibmemo and passing in two parameters, index and cache, which will be an array. Now, this cache is very important, and it is how our memoization will work. Whenever we calculate a Fibonacci number, we will put it into this cache. Then, as our function gets called recursively, we will pass this cache in as a parameter every single time our function is called, so we never lose reference of the numbers that we already calculated. Now, the first time this function is called, we don't have to pass a cache into it because we know that no Fibonacci numbers have been calculated yet. So we can call our algorithm right down here, like this, and only pass in the index we are looking for. Since we are initially calling our fibmemo function without passing in a cache, we need to define the cache inside of our function. So that is what we will do first. We will say our cache either equals the cache that is passed in, which will happen when we call the function recursively, as you will see, or our cache equals an empty array. This is essentially the same as passing in an empty array down here as the initial cache. If we do this, then we do not need to redefine our cache up here. But our way is cleaner code, so we will take this array out. Okay, great. Let's get into coding out the meat of our algorithm. Again, this Fibonacci algorithm will also be recursive, so we know that there is going to be a base case and a recursive case. Let's start by coding out the base case. So our base case is going to be a little different this time than it was last time. Basically, the first step that we always want to take inside of our function is to see if the index we are looking for has already been calculated and is inside of our cache. If it is, then we can simply return it. So that is our base case. So we will say if cache at the index exists, then return cache at the index. So whenever this function is being called, which could be recursively down the line somewhere, if the index has already been calculated and it is inside of the cache, we simply want to return it. Great. Now let's deal with our recursive case inside of the else block. Basically, all that we want to do in our recursive case is calculate what Fibonacci number is at the given index and place it into our cache. So we are going to have an if-else statement in here, and this section of our algorithm will look very similar to the previous Fibonacci algorithm that we built. Inside of here, we will say if index is less than 3, then we just want to return 1. Else, we want to say that the cache at this index equals fibmemo with index minus 1 and the cache passed in, plus fibmemo with index minus 2 and the cache passed in. This section right here in our else block is where you can see our fibmemo function being called recursively. And as you can see, we are not returning anything from this else block. Instead, we are just calculating all of the numbers we need to get up to the index we are looking for. So down here, we have to finally retrieve and return the correct index. So we will say return cache at the given index. And that is it. That is how our Fibonacci memoization algorithm works. Let's test it to make sure that it works correctly in the next video.